Hello, and welcome back to another video tutorial on Docker. In the last video I covered what Docker is, some of the things it's good at, and some basic commands to help you get started. Today I'll be building off that knowledge by showing you how to provision your own containers. So what does provisioning your own containers mean? Provisioning a container just means that you're setting up the container before the main program runs. Remember in the last video when we spun up a new container and bash was the main program that ran for us? Bash was able to run just fine because the only dependencies bash needed was already inside of the Ubuntu image that we started with. Well, imagine that we wanted to run something other than bash as soon as we start the container, such as, let's say, our own Python application. We would need to set up, or provision, the container with Python along with any additional Python libraries that our application would need. There are two primary ways to do this. I'll show you one of these ways in this video, and I'll show you the second way in the next video. Let's start off with a very basic Python application. So our goal here is to run some very basic Python code as soon as we start the container. The Python program asks the user for the user's name, the user enters their name, and the program says hello to them. The first way to start provisioning your container would be to, well, do whatever your normal workflow would be, but inside the container. For example, let's spin up another container from the Ubuntu base image. This time, let's actually give a name to the container without Docker making up a name for us. Let's call it PyApp. Now that we have a container up and running, let's install Python with apt install python 3. Wait a second, it looks like it can't find Python. What gives? You need to make sure that you perform an apt update and an apt upgrade on your system to make sure that when you use the apt package manager, it will know where to go out to on the internet to find the software packages that you want to install. Now let's try to install Python again. Now that we have Python in this container, let's transfer over the Python script. But wait, this container is only exposing its bash shell to you. So how can we get code into this container? For those of you familiar with the command line, you may know of command line text editors like Vim, Nano, Emacs, and so on. These editors can be used to write files via command line, and there are several of them. If you're interested, you can type in command line text editors into Google and you can find out more about them and how to use them. For the purposes of this video, I'll be using Vim. Wait a second, it looks like there's no Vim. This is because Vim is not installed yet. If you're familiar with Ubuntu in general, you would know that Vim comes as default in most Ubuntu distributions. Well, the base Ubuntu image we use to spin up our container is a very minimal version of Ubuntu. It has just enough dependencies to allow you to do basic tasks. This is actually really nice because it allows you to build up exactly what you need without having too many unnecessary binaries or libraries that you never intend on using for your application. So let's install Vim like how we installed Python. So after installing Vim, now we can copy and paste our Python code in a file inside the container. First I go to where I want my file to be. Then I type in Vim and then the name of the file I want to create. Vim has two main modes, command mode or insert mode. By default, it's in command mode. Let's put it in insert mode by pressing I. Now we can paste our code. To save and exit, let's get out of insert mode and go into command mode. We do that by hitting the escape button. The command to save and exit is :X and then press enter. Let's test out our program. Awesome, looks like it works. So now what? Well, our original goal was to get our program to run as soon as the container starts. Unfortunately, we can't do that with this container. If we open up another PowerShell and run the command docker ps, you will see the container that we are currently running. Take a look at what it says under command. It's the bash command. This was the default starting command we used when we spun up the container from the Ubuntu image. This can't be changed for this container. This may seem weird, but I kind of like this feature of Docker. I know that however a Docker container gets spun up with Docker run, it will always use that starting command, even if you stop and start it again. It also encourages you to only use a Docker container for a single purpose, which is the way it should be. So then, how do you start a container with the program you just made inside a container? Any guesses? The answer is to create an image from your current container. A new image created from your container will preserve all the dependencies and files you made while in the container. It's pretty easy to turn a container into an image. You just run the command docker commit, your container name, the name of your new image you want to create, and optionally, a colon with some version tag like 0.1. If no version tag is specified, it will default to the word latest. After you run this command, you can see that if we run docker images, we have a new image now. Notice the size difference between the base Ubuntu image and our new image. The size difference comes from all the installations we did while in the container. Now let's perform the docker run command with our new image. Notice I'm using pyapp2 here because if I tried to name this pyapp, Docker wouldn't let me create the container because a container with that name already exists. Wait a second, this is just running bash. Any ideas why? This is because we're still using the Ubuntu base image as a, well, base. So it makes sense that it has the same functionality if we don't enter in any command. Later in this video, we'll go over how to specify a default command. In the meantime, let's remove the pyapp2 container we just ran and run the container with our new Python program. The command would be the following. Awesome, it works. Let's look at the container state. Notice how pyapp2 container has the Python 3 command instead of bash. Also notice how this container is no longer running. This is because the sole purpose of this container existing was to run that single command. Once it's done running, the container stops running. This was similar to how the container for a bash command would keep running until you enter the exit command. Let's start back up the container. Great, this works exactly how we expect. There's just one thing I would like to change though. Because the container has the exact same functionality when I'm spinning it up for the first time from an image versus when I start it up again after it's been stopped, I would like to destroy it after the container has done its job. If you don't need to keep your container hanging around after it's been ran, then it's good practice to clean it up when the container stops running. Let's manually delete this container one last time. Now let's spin up the container with the following command. Notice how there is a --rm in the command now. This means that the container will remove itself when it's done executing. Now there is no trace of our pyapp2 container existing. From now on, whenever we want to run our program, we can just call the docker run command. If you ever want to make edits to the container, you can just spin up the image with the bash command, make whatever installations or edits that you need, and then make a new image from that container. What if you wanted to package up your image and send it to someone else to use? The docker command for this is docker save-o, the name you want to give your new file along with the tar extension, and the image you want to export. I will remove the current image I have of pyapp image. And now I will load in the image I just exported. Congratulations, you just learned one of the ways of how to provision a container. However, there are better ways to provision containers. You will undoubtedly see this way being done in the wild, and I wanted to make sure you were all aware of this way. In some cases, this may even be preferred depending on what you are doing, but in most cases, it is better to use something called a Docker file to provision a container instead. This will allow you to know exactly what is being put inside the containers instead of just receiving a Docker image that is a tar file and you have no idea what's inside. We will cover this second way of how to provision Docker containers in the next video. Here are all the new commands we covered in this video. We covered Docker run in the last video, so I highlighted some of the arguments in red that were new in this video. This wraps it up for this video. Thank you all for watching, and I'll see you guys in the next one.